This video is made for the purpose of answering the question that what is enthalpy? Okay, so enthalpy, which refers to a state of the system, just like internal energy as we have studied, is a measure of energy in the system, which is the form of energy to consider when first, the system is open with inflows and outflows. Second, the system is closed and operating at constant pressure. So let us talk about first enthalpy for open system. Okay, for that we have to learn about flow energy first. Now, as we know that control volumes involve mass flow cross their boundaries, so energy is required to push the mass into or out of the control volume, and this energy is considered to be part of the energy of a flowing fluid, so-called flow energy. Now let us talk about relation for flow energy. For that, we have to consider control volume as shown here, and this is showing fluid element, okay, having uniform properties throughout like volume, pressure and mass. Okay, and this is an imaginary piston showing fluid upstream. That is, an imaginary piston is considered, actually that piston is just a representation of the fluid upstream forcing the fluid element considered into the control volume. The fluid element chosen, this chosen fluid element, must be sufficiently small so that it has uniform properties throughout, and similar phenomena will be there for forcing fluid element outside the control volume, thus maintaining the flow. Now, relation for flow energy continuing. Okay, for that also we have to choose a control volume CV, and this arrow is showing the pressure exerted by the fluid here, and this is the force exerted by the imaginary piston. Okay, and this is whole length L, and this is the area of cross section of the fluid element. Okay, where F is force and P is pressure, as you know already. Now, force applied on the fluid element by the imaginary piston is F is equals to pressure into area. So for pushing entire fluid up to length L, the flow energy is F into L, that is parallel PV. Okay, so enthalpy is actually defined so that by using it instead of internal energy to represent the energy of a flowing fluid, one does not need to be concerned about the flow energy. That is, enthalpy, which is denoted by H, is a combination property. H is equals to U plus P into V. Now let us talk about enthalpy for closed system, okay, as we have talked about for open system. For this, let us take an example of a piston cylinder arrangement containing an ideal gas at P pressure, T temperature and V volume. So this is our system, and energy is given to this system in the form of either heat or work. This piston going upwards for gases to flow. Here pressure is constant and temperature and volume increases as a result of this energy. So now suppose energy is transferred to the system, as a result of which its temperature increases and thus internal energy. Here one point to keep in mind is that enthalpy for closed system is defined only at constant pressure. So volume of gas increases to keep the pressure constant, or we say that PdV, that is boundary work, is done by the system. As for ideal gas, T is proportional to V at constant pressure. Thus, piston starts moving upward for the flow of gases to take place in the upward direction. In this case, we say that energy transferred to the system either in the form of heat or work is the enthalpy of the system, that is Q is delta U plus P delta V, that is delta H. Thank you.